Okay, I want to walk you through how to perform a Grubbs test for outlier data and how to compute a confidence interval using Excel, pretty simply. So I have some generic measurements here. This could be, say, the results of a titration. It could be whatever set of data or series of data that you have that you want to evaluate whether or not there's outlier data. These are my measurements. What I'll do is make a separate column here called trial, meaning the number of measurements that we have. I'm just going to type 1, 2, 3, and what's nice about Excel is if you have 3 repeating values and then you highlight them and grab this corner value or corner drag option, it'll repeat those values so you don't have to type them all in. That's nice. So I'm going to bold that, and what I'm going to do first is just compute the average of each of these. Actually, I'm going to do that here. So average equals average, and I'll grab these data, pop that in there. I will compute the standard deviation here, which is equals STDEV, parenthesis, grab my data, close parenthesis. I'm going to count, which is I'm going to create an n value for how many measurements I conducted, which is equals count, which is handy for a variety of reasons. It may seem obvious because we already have 7 here, it's really clear, but when you have larger data sets, it's nice to know how many you have, and it's also nice to automatically compute if you remove any of these data as outliers. Okay, so this is what I'm going to start with right now. I'm going to make a separate Grubbs column to compute my Grubbs value. So I pasted in the equation for computing the calculated G value, which is the Grubbs value here. This comes straight off the statistical decision tree that we talked about in the previous videos, so you don't need to paste this in. This is just for reference for the video. So to compute the Grubbs value, that's going to be equals, and then notice it's an absolute value sign, so I'm going to type ABS, that's absolute value, and I'm going to put a parenthesis here for x value, which is this one, and then I'm going to subtract from that x bar, which is our average. I'm going to click there, and I don't want this value, the average, to change as I drag this formula down, and so what I need to do is put dollar signs in between the row and the column markers. On a PC, you can do this really quickly by just hitting F4. And notice how I have dollar signs now. That's going to lock that cell number into my formula so that it doesn't move as I drag this down. I'm going to close the parentheses. I'm going to divide then by the standard deviation, which is here. I'm going to protect that value as well by clicking F4. I don't want that to change. I'll click Enter. That's going to compute my Grubbs value, and then I can drag that down and compute a Grubbs value for each of these things. Okay, so I just grabbed a Grubbs table off the internet. So this just comes from an open source chemistry textbook from the appendix. And what we have here are 2 columns of data based on whatever the confidence we want. This is the alpha value, so we talked about this in the previous video. So if we want 95% confidence, we're going to use an alpha value of 0.05 here, so 1 minus the confidence. So that's 0.05, and then n being the number of measurements here. So we have 7 measurements, so we'll go down to 7 and then look at our value at 95, which is 2.202. So what we need to do then is compute any excluded data. We'll look at each of our values here. So we can look at this, or you can set up a formula that says highlight a value that exceeds a certain value. That's a lot of work, but you can do it if you have a large data set. I'm not going to do that here. I'm just going to look at my Grubbs values here. Anything that's in excess of 2.202 would be a rejected data point or excluded data point. We can see that this one is actually in excess of that, which means this measurement value needs to be excluded. So instead of deleting data, I don't like to do that. I'm going to just cut that, and I'm going to paste it over here just so that I always have a reference for what I excluded. I don't want to delete it entirely. But notice now in my measurement column, my count automatically updated to 6, which is useful. Okay, so this is my new data set. Okay, so to compute the confidence interval, we need the equation for the confidence interval, which I again just grabbed straight off of the decision tree here, or you grab it out of your textbook. So remember, the confidence interval is going to be a range of values where it's really your average plus or minus whatever the confidence interval, which is going to be the t value, the t statistic, times the standard deviation divided by the square root of n being the count or the number of measurements there. So that means we're going to need a t value. We can compute the t. I'll just write t calc here. Remember, you can do a t-test using the data analysis package, or you can actually just compute t values directly here. So what I'll do is take t equals t in verse, and then I need to type in, you can see it's prompting me to type in the probability first. The probability here is the alpha value that we've been using, which is going to be 1 minus the confidence range that we want. So 1 minus the 95% is going to be 0.05, and then comma, and now I need to insert my degrees of freedom. Remember, degrees of freedom are always going to be n minus 1 in this case, so I'm going to click my count and then type -1 and then close the parentheses. Okay, so that's my t value there that I'm going to use to compute the confidence interval. So now I'll type in 95% CI, and I'm going to say that is equal to my t value times my standard deviation divided by the square root of my count here, and that's going to give me 0.04157 as the plus or minus component. So to compute the actual range of confidence at 95%, I would take this value, the 0.041, and add it to my average and subtract it from my average, and so I would have a range of values. Notice that you can compute a 90% confidence interval here by changing the t calculated from 0.05 to 0.1, so I could just click a 0.1 there, and that's going to change my confidence range to a bit smaller, right? And that should make sense that if my range is going to get smaller as my confidence gets smaller, meaning that there's the more confident I am that a value will lie within that range, the bigger the range gets, right? I get less confident as my range gets tighter and tighter and tighter and tighter and closer to my average. So just to do a last demonstration here, I'll do a 50% confidence, and notice the value here at 90 is 0.03, the value at 95 was 0.04, let's do 50, so I'm going to recalculate this and put a 0.5 here, and notice that my 50% confidence interval drops all the way down to this tight range of 0.01. Okay, so I just want to lastly iterate then that if you are using this decision tree, the place that you often use a confidence interval is when you're doing a test to evaluate whether or not your data set is statistically different from a compared known or true value. So like a standard reference material or an established value in the literature in the community. In that case, you'll compute the confidence interval at whatever confidence, normally 95%, and then you'll take the known value and see if it lies within the range. If it does not lie within your range at 95% confidence, then that value or your data set is statistically significant in its difference from the true value. If that value, the standard value, does fall within the range of your confidence, then you can say they're statistically insignificant in their difference.